So this is question number 3 of the January 2015 paper. This one is a practical experiment to investigate the effect of temperature on the rate of starch digestion by the enzyme amylase. Carries out the investigation at room temperature of 20 degrees C. So you've got the list of what is happening in this experiment. You need to read that carefully. And then at the end we've given a photograph of the results at the end of the experiment when all the wells had mixture added. Important thing to remember, just looking at this to begin with, is that this is the result after 1 minute. That would mean 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes, 8 minutes, 10 and 11. It's obviously important later on. That essentially was at 0. That was the start of the experiment. So it's giving that information there. Obviously, apart from just being a practical question, there is some knowledge you needed to have to answer this. The idea that in the present, well, 2 things you need to know. First thing you need to know is that amylase is an enzyme, and amylase's job is to convert starch into maltose. Technically, we may have learned that as glucose. Technically, starch is converted into maltose, which is sort of 2 glucose molecules joined together. But what you need to do essentially know is that starch is broken down by amylase. The other thing you need to know is that iodine, again this is something you will have learned at some point, iodine in the presence of starch will go from a brown / yellow colour to blue / black colour. Therefore, in this experiment, we can see that here, 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 and here, there is still starch present because the iodine is blue, black, it's changed colour. Whereas from here, 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 here onwards, starch is no longer present because the iodine hasn't changed colour. Okay? So looking at that, that's what we need to interpret. It's going to be important later on. So if we go down, we look at the first question. Give one safety precaution that the student should take when carrying out this investigation. Well, because you're using iodine, okay, iodine is potentially dangerous. To this experiment, a suitable precaution would be to wear safety goggles. Not goggles, sorry. Goggles or safety specs. Another appropriate one would be, perhaps wearing gloves. So if you have potentially sensitive skin, you might want to wear gloves to react the iodine. It needs to be specific to the actual risk of the experiment. So the main risk of the experiment is the iodine, therefore we need to protect ourselves from it. Stating something like standing up, tucking bags is not relevant to this experiment specifically. Okay, and if you look at that revision sheet I've given you on CORMS, on the back there are some guidance there to help you pick what safety precaution that you should use for each experiment, so refer to that. Again, how many minutes did the samples of the mixture spotting? How many minutes did the samples on the mixture added to the spotting time on the photograph represent? Well, we can look up here and realise that that's 11. Okay, a lot of people got that wrong. Okay, it's 11 minutes because of the reason the first one was essentially taken at 0. So that's why we can see down here that's the 11th minute. Explain the purpose of the following steps in the student experiment. Okay, so step 4, let's remind ourselves what step 4 is. He rinses the outside of the syringe with water from a tap. He's done that, the student's done that after he's added starch suspension to the well. Okay, the reason he's rinsing it off is to remove excess starch from the outside of the syringe. That's obviously important that you remove that excess starch, because if you don't, what's going to happen is when you dunk that syringe, so if we imagine this is our beaker of starch here, out of the way. So here's a beaker containing starch. When we dunk that syringe in there to extract out the starch, all on the outside of here, you're going to have starch. Okay. If you don't rinse that, you've got a risk of taking that to your next beaker. The beaker, in this case, if we just remind ourselves, the next beaker that it's going to go into is the amylase suspension. You're going to contaminate this amylase suspension with any excess starch that might be on the outside of that syringe. That's why you're going to wash it off. Step 7. So step 7, he rocks the syringe containing the mixture gently backwards and forwards. Again, pretty straightforward. Is that you want to ensure, so what's happening here is you need to ensure mixing of starch and amylase. You want to make sure they're fully mixed together so that the starch has a proper opportunity to, the amylase has a proper opportunity to break down the starch. Lastly then, 11, he also keeps the syringe containing the mixture in a water bath at 40 degrees C between drops. The reason it's kept at 40 degrees C between the drops is to make sure that, ensure contents of the syringe are kept at a constant temperature. If you didn't keep it in the water bath, that first drop of starch would have certainly been at, the first drop of starch that was being kept, is it starch in there? Amylase and starch suspension, okay? The first drop would have been at that 40 degrees C. If that was just left on the bench, that's slowly going to cool and cool and cool till by the time you're getting to the 11th drop, it may have dropped by sort of 10 degrees C, and therefore you're not actually keeping the thing you're trying to say changed constant between. So water baths are a really great way of keeping temperature constant, whatever your experiment is. Identify 2 control variables. Again, this is something we kind of discussed in sort of practical methods. It's an investigation to see the effect of temperature on the rate of an enzyme-controlled reaction. Okay, we know that enzymes are affected by substrate concentration, enzyme concentration, pH, and temperature. Identify 2 control variables to controls this experiment. We're just going to state the 3 things that aren't being changed. So we could say here the concentration / volume of starch, that's the substrate. We could say the concentration / volume of amylase. We could potentially talk about other things as well here. Talk about pH. We could talk about, we could put pH down. We could talk about the same amount of iodines added. But really, those are your 2 main answers there. Really important to note, what I definitely didn't say, and you mustn't say, is amount of starch or amount of amylase. Please state either the concentration or volume of the starch and amylase solutions. Don't say amount. Name the independent variable. Okay, reminding yourselves again, independent variable is the thing you changed. So in this experiment, the thing that was changed for the experiment was temperature. That was what we were investigating the effect of. Okay, carrying on down. Using the photograph, explain how many minutes took the reaction to be completed at 20 degrees C. Let's remind ourselves. So 1, 2, 3. Okay, after between 5 and 6 minutes, okay, starch was still present at 5, but at 6, there's no starch present because the iodine has not changed from this browny yellow colour to the blue-black. Now, I appreciate it's a black and white picture, therefore you can't see the fact it's sort of a browny yellow, but you can see that it's definitely lighter. It's not this inky blue-black. So sometime between 5 and 6 minutes, the starch is no longer in that solution, which suggests it's all being broken down there. So it's between 5 and 6 minutes. You were allowed to just say 6 minutes. So after 6 minutes, it had definitely disappeared. How do we know that? Okay, Well, we know that is because starch was still present at 5 minutes because iodine had turned blue black. However, after 6 minutes, the iodine didn't change colour. Therefore, no starch present. Why was there no starch present is because amylase had broken down all of the starch. Okay. If the reaction hadn't finished, there was still some starch there, then at 6 minutes it still would have changed colour. It hadn't. Now, what a lot of you got wrong on that question is you had you kind of misunderstood what iodine was doing. You talked about iodine not changing colour after 6 minutes, and that's wrong. Okay, iodine started, it will only change colour in the presence of starch. So it wasn't changing colour and then it only changed colour after. It wasn't indicating the end of the reaction. What iodine does, it shows the presence of starch. Okay, question E. The results for the spotting tile at 40 degrees C would be different from the trial carrot at 20 degrees C. Describe how the appearance would be different. So we know that temperature affects enzyme reaction, and if we just sort of remind ourselves quickly, what happens is, let's undo that. Is it just going to keep playing around? Roughly, if we're to draw an enzyme reaction graph, we sort of have 0 here, we have 100 here, and we have 50 there. We see the rate of an enzyme control reaction would sort of increase, sort of a rubbish scale, with the peak kind of being, if this is a human enzyme, around sort of 38 degrees C. 20 would be down here, 40 would be sort of here. So at 40 degrees C, the iodine is going to be closest to its optimal temperature. So at 40 degrees C, the reaction would complete faster at 40. Why is that? It's because the enzyme is closer to its optimal temperature / the enzyme and substrates have more kinetic energy, so they're moving around faster. Let's refer back to the actual question. It says describe how the appearance of the results were different. Is that there would actually be fewer wells with a blue-black colour. Okay, because we remind ourselves, if we move up here, we look at the wells, remember that it only changes colour in the presence of starch. If the amylase enzyme is working faster, there's going to be less starch around, they're going to disappear quicker. Okay, last question. Okay, actually I've kind of answered 2 in 1 there, that's my fault there. So there would be fewer there because the amylase is working quicker, so it'd be faster. Explaining, okay, that's where we talk about the enzyme and substrate having more kinetic energy. When they have more kinetic energy, it's going to lead to more successful collisions / more enzyme substrate complexes formed. If you don't know what I'm talking about there, then you need to really go back and look at your understanding, look at your revision notes, you might need to go back and revise enzymes if you're not sure what an enzyme substrate complex is. But I think where a few of you fell into trap on those two questions is that you saw 40 degrees C and just immediately assumed it's denaturing. It's not going to be denatured at 40 degrees C. That's very close to the human body temperature, 40 degrees C, and therefore it's going to work optimally. Had it said, describe the results at 80 degrees C or 60 degrees C, what would actually happen is all of them would be black, because at 60 degrees C the amylase enzyme would probably be denatured. 40 degrees C it wouldn't. Okay.